So following on from the previous two videos, we are now at this stage where we're trying to understand this. Whenever you apply this transformation and it equals a negative version of the original, then you can say it's symmetric along the origin or along the pole. So what that means is, let's say this has an angle of, let's say, pi over 7, and it has a radius of, let's say, 5. So being symmetric along the pole means this. Well, the angle will still be the same, pi over whatever I said earlier, but then the radius is negative, meaning negative 5. So you're going in this direction. So this is positive 5. So this is negative 5. So this point here gets mapped to here. That's what it's meant by being symmetric along the origin. So whenever you apply this transformation and it equals the negative version of the original, then you can say it's symmetric along the origin. So what? Now we're going to try and understand what is meant by this. So now cast your mind back to our section on functions. Let's say we've got this function here, f of x equals x squared. So hang on, one more step. We are trying to understand this, but in order for us to understand this, let's try and understand this. So this is your variable here. This is also your variable. This is your constant. This is also your constant. So let's try and understand what is meant by this. So when you have a function f of x equals x squared, when you apply this transformation, it's like me saying what goes in here. Well, what goes in here would be you putting this into here. So that would be f of 2 take away 2, which is f of 0. So f of 0 is really you stealing this point and moving across. So it's like me asking you what goes along here. It's really you stealing f of 0, which is this origin here, and then you drag it to the right. So it gets dragged to the right. What goes in this box is you putting the 3 into here. So that will give you f of 1. Well, f of 1 is really you stealing this thing here and then moving across. So it's you stealing what was over here and then moving across. So this transformation is really dragging everything to the right. It's dragging everything to the right. So in Cartesian form, when you apply this transformation, it's dragging everything in the horizontal direction. But then in polar form, when you vary theta, you're actually varying the angle. You're dragging it back and forth. You're rotating it. In Cartesian form, when you apply this transformation, you're sliding everything back and forth in the horizontal direction. In polar form, if you vary theta, you're actually varying the angle. You're rotating it in effect. So when you apply this transformation, when you apply this transformation, it's really you doing this. Bear with me. It's really you doing this. It's really you doing this. You're actually just rotating it. So for you to apply this f of theta plus pi, well, the positive angle goes in this direction, but when you plus an angle, you actually go in the negative direction, if that makes sense. Because hang on, bear with me. Because if you look at this here, when you take away here, you move to the right. When you add 2, then you move to the left. So when you apply this transformation, if you add pi, bear with me. If you add pi, then if you add pi here, then you've got to go in this direction. If you take away pi, then you go in that direction. So what this is saying is, bear with me, I've lost my hand. So let me bring back my hand. Okay. So if you apply this transformation, it means this. It means you've got to rotate it you've got to rotate it clockwise by pi. So that means it's you doing this. Hang on. So when you apply this transformation here, it's really you doing this. You rotating it. Bear with me. This is the best that my animation will allow me to do. So wait that. So you rotating it by pi would be you rotating it in this direction here. So now it looks like this. So bear with me. So when you apply this transformation, it's actually you rotating it in this direction, because here it's a plus. So you rotate in this direction. So now after applying this transformation, now it will look like this. So if you look at this, this is the exact same as the original, but in the negative direction. So the original was something like this. Hang on. The original was this. So let's say this point here is, let's say this angle here is, I don't know, let's say it's pi over, I don't know, pi over 5. And the radius here is, let's say the radius here is 6. So now when you apply this transformation, it will look like this. But then if you now look at this here, don't forget this thing here saying the radius here is 6, but now it's negative 6. So the angle stays the same, but here it's negative 6. So the angle is staying the same. So you know it's along this line here. But instead of the radius being positive 6, now it is negative 6. So it should take you to this thumb here. Okay, so whenever you apply this transformation, meaning you rotate it, and it equals the negative radius here, if that makes sense, then you know it's symmetrical along the origin, meaning that this point here gets mapped to over here, this point here gets mapped to down here. It's symmetrical along the origin. Okay.